project that you guys are going to be working on is titled Aggregations and Collisions. I need you guys to remember that, okay? So write it down, Aggregations and Collisions. One of the things that I've noticed over the years I've been teaching here is that students will go through these projects and then like 2 years later when they're doing their portfolio and they're ready to transfer, they'll come back and ask me, so what was this one called? And I need you guys to remember them, okay? So in case you don't remember the first one was called subtraction, spatial and surface, or surface and spatial, either way, okay? All right, so we're going to be looking at aggregation as a means of designing something. And you guys are going to start out by doing form studies, okay? So aggregation, I have a definition over here. I'll walk over and read it to you, all right? It says, aggregation, the formation of a number of things into a cluster or grouping, okay? So whereas your first project was about taking one object and removing from it to form a thing, okay, and expressing that subtraction, that becomes another thing that's really important for you guys to understand. All of our formal methods that we're teaching you are about expressing that subject, okay? So you guys are required to build all of these crazy boxes, right? You guys got lots and lots of boxes. One of you actually was able to do them all. But these are many, many pieces, right? And these pieces need to be brought together into a grouping, all right? And that grouping needs to come out looking kind of cool, right? We don't want an ugly-ass thing. We want a cool-looking thing. And it becomes important that you guys learn some of the techniques that can help you to achieve something that is more visually interesting than something that is sort of just there alone, okay? As with all of the projects that we do for the entry-level students, we put limitations on you, okay? So in the first project, you were limited to a rectangular object, actually a perfect cube, right? And all of your cuts had to be orthogonal, that is 90 degrees to all of the other surfaces. You were also required to keep the corners and stuff. One of the other things that students don't seem to understand is that these sort of formal methods are just a starting point, okay? And that we put a lot of limitations on you because we need you to sort of master the course content or the content that we're teaching without getting too many distractions and going in too many directions, okay? But with subtraction as an example, since you guys are finishing up that project, I showed you guys the Apple logo, right? Yes. Okay, is the Apple logo perfectly square and rectangular? No. Is the bite out of the Apple logo orthogonal? It's not. So subtraction as an idea, as a formative idea, an idea that can give form to something, has many, many, many different avenues. We chose to kind of limit you guys down one so that you guys could focus and learn. All right? Same thing applies for aggregation and collision, right? We're going to limit you to doing things, again, orthogonally, that is at 90-degree angles, okay? And we're going to request that you perform a certain amount of collision, okay? So I mentioned that I only gave you one definition rather than two, but the name of the project has two different components in it, right? Aggregations and collisions. So the second part of the project deals with taking two volumes, okay, back to the collision part, and pushing them into each other. Not so that they land on a surface, but so that they become a new object that is very different than the others, okay? So those are some definitions that you guys need to learn, all right, and some thoughts and sort of information that you need to have in your notes. Because I'm going to ask the beautiful Janet over here to develop some quiz questions right now based on what I've just talked about. Okay, so you can stop the recording and then you can re-review